Hello friends, in this tutorial we are going to learn about binary search trees. What are binary search trees? Binary search tree is a non-linear data structure and all nodes of the left subtree of binary search tree must be less than or equal to the root node. If 1 is a root node, okay, let's take 5 is a root node, then before 5 we have 1 2 3 4, those all are less than 5, so they come to the left side of the binary left side. That means the less than the root node should be on the left side and greater than the root node must be on the right side. So we can take 4 like this, and 3 is less than this, 2 1 like this. Left, right side greater than the 5, 6 7 8 9 like this. In this way we can construct the binary search tree, and this nodes, even the subtrees should also follow the binary search tree rule. That is, for the subnodes also, left and right child must be less than or equal to this root. And now let's consider an example. Let's take alphabets G, H, M, I, J, K. Here G is the root node. Let's represent it in the form of linked list. G, H. H is greater than G, so we represent H here. Next, M. M is greater than H, so we represent M here. And next, I. I is greater than A, B, C, D, F, G, H, I. It is greater than H but less than M, so we represent I here. And J. J is greater than G, J is greater than H, J is less than M, but we have I over here, so what we do, we put J here because J is greater than I. Next, K. I, J, K. So K will come here because G, H, M on left to this I, right to this J, so J right will be K. And if we represent this as a tree, G, H, M, I, J, K. Excuse me. In this way we can insert the elements into the binary search tree. Now, if you want to insert an element like what we say, G, H, M, I, J, K, let's insert if N, it will come here. Let's insert X. Let's insert X in this tree. Insert X. So when we want to insert X, we make sure that G is X is greater than G, so it comes on the right side. We have H already and we have M already to it, so M and X is greater than M, so X comes here. Remaining I, J, K will be here. X is greater than M, so X will be placed here. In this way we can insert the element using binary search tree. And for searching of an element, how we search the element? Let's consider a left side also. This is 5, This is 3. This is 2, 4, 6, 8, 7. 6 greater rate 8. So 7. Yeah, fine. So let's search for the element 8 here. So when we want to search for the element 8, first we check with the root node. While checking with the root node, 8 is greater than 5. So we ignore this left part and we come to the right part. We see 6 and 8 is greater than 6 also. So what we do? We go to the right part. We go to the right part. So we find 8 equal to 8. Here in this way we can search for the element. Suppose if we have any left hand side, we ignore this as 6 is less than 8. So now insertion is done, searching of element is done. Now let's see how to delete an element from the binary search tree. Deletion. Suppose we have A, B, C. Okay, smaller, right? Let's take B, A, C. So if you want to remove the child node, let's construct it like linked list B, A, C. This is null, this is null. So if you want to remove A or C, these are child nodes. So we can make, if you want to remove A, we can make null here. If you want to remove C, we can make null here. Suppose if you want to remove A, how we represent it? B, and here C, null, null. In this way we delete the child node. And let's take another example. This is first. Let's take second one. Because we have D, B, E, F. Let's construct a linear linked list D, B, E, and F. This is null, null. This is null, null, null. Now we want to delete E. How we delete this middle element is B. So if we want to delete this middle one, it is associated with this F. So what we do, we give this linked node address to this D. So on deleting E, we make like this B, null, and F like this. So deletion of E is done. So for deleting the nodes in the binary search tree, we have 3 cases. First thing is, let's consider this node as U. If element U has a leaf node, that is first condition, and element U has a left or right subtree. First is leaf node, second is it have a left or right child, that is it is non-leaf node, and third is element U has both left and right. Both left and right children. Leaf node, we have seen this condition, that is it doesn't have any children. So if it doesn't have any children, we can just make it null. If it have a children, that means it have only right child, either right or left. This is second condition, it have right child. So what we do, we give this address to D on deleting this. So another condition is, we have if it have both the left and right child. If you want to remove this E, how we make it is let's take one more example to see how this both left and right children, if it is present, how we do this. Third example. So G, B, M, K, I, Q, Z, E. This is textbook example. So now if you want to delete this M, it have left child and it have right child. How we do? Here Q is greater than K. So we take Q over here. So that Q link will be given to Z. Greater one we have to take. So we get like this. B, E, Q will be here, K will be here, Z, I. In this way we can represent. As Q is greater than K, we put Q over here. We give address of Q to G. And in this way we can delete the element in the binary search tree. And traversals, three traversals for binary search tree. How we traverse is the same old thing as we have for binary tree. That is, one is level order, second is pre-order, third is post order, fourth is in order. Level order, it goes level by level. Pre-order is first root node, next left child, next right child. Post order is first left node, next right node, next root node. In order is left in middle root node, next right node. In this way we traverse the binary search trees. So in our next tutorial we will learn about AVL trees. So if you like this video, please do like, share, comment, subscribe and click on the bell icon so that you will get to know about the new videos which will get uploaded. Thank you.